ventricle, depolarization of the ventricle occurs, and that's read as the whole QRS wave, and we have ventricular systole at this point. And then finally, our last, let's see, oh, I don't have it. Our last one, our T wave, is when this depolarization reverses itself. And all of these myocardial cells are back to normal. That's called repolarization, and that is what our T wave is. Repolarization of the ventricle. Okay? So just remember that this electrocardiogram reads the electrical current going across the myocardium of the heart, but it's up to you to actually extrapolate and imagine the contraction that should occur as the current goes across the myocardium. Now, we'll go over some of this next week, but I just want you to think about something. Here's our normal strip for an electrocardiogram. And typically when you look at electrocardiogram, you just see all these lines, you have to orient yourself when you are faced with an electrocardiogram. The first thing you want to do is look for the peaks. Look for your one main peak that you see. And that actually is going to usually represent your QRS wave. Okay? And you know that this is the point where our ventricles are depolarizing and the ventricles should be contracting. Okay? And you can just go to the tip of every peak, and if you have if you have a strip that's actually 1 minute long, you can actually, or even 30 seconds, you can actually count how many beats and figure out the heart rate. Okay? You can also do it by boxes, but we're not going to get into that. Now, once you've oriented yourself and you've found that peak, their QRS peak, then you look to the left of that peak and see if you can find the bump on the left of the peak. Every peak, every QRS should have a bump on the left. Okay? And that's your P wave. Now look at the right, and there should be another bump to the right. And that is your T wave. So the P wave is going to be polarization or depolarization of the atria and contraction of the atria. And the T wave is repolarization of the ventricles, relaxation of the ventricles. So that's how we find or orient yourself to find your wave. And what if you get a reading and you find your QRS there, and you look to the right and you have a T wave, and you look to the left and there's nothing? What if there's nothing there? Like down here. You go here, you find your peak, you look to the right and there's a T wave, and you look to the left and it's just a line.
No T wave.
I think those not functioning. That's right. There is no signal going from the SA node to the AV node. There's no signal going across the atria. Okay? Now, typically, when there's an absent P wave, that part of the cardiac conduction system is not working. And very often, something else will have to take over to say what the overall heart rate will be. If there is no input from the SA node, if the SA node is damaged, often the AV node will take over. If the SA node and the AV node are both damaged, sometimes some atrial cells will take over. If that happens, the person will end up having the whole heart will go at the synctium that the atria want, which is like 120 BPM. Yeah, so then you'll get atrial tachycardia. That's atrial tachycardia. But sometimes, occasionally, a couple of ventricular cells will take over, and then you're going to have a really slow heart rate. You'll have a ventricular bradycardia. So there's different ways that this could occur. But just understand that when you're missing a P wave, there is a problem with portions of the conduction system. The SA node very often can be damaged. If that happens, the AV node will take over. Now, notice this word here, pacemaker. That's the name given to your SA node because it is actually determining your heart rate. It is actually the natural pacemaker of the heart. Okay. Now we're going through this a lot. Here's a couple of other examples. All right. Now, what if a person has had a heart attack, and the heart attack has damaged one of the bundle branches? This is very common. People have a blocked artery that goes down the interventricular septum, and damage to one of the bundle branches, the right bundle branch, for example, could occur, and that means that the signal going down the right bundle branch may be blocked. It may not be able to get through the scar tissue that is now there. And what usually happens is the signal doesn't go all the way down to the ventricles. And very often you'll see that these people have skipping heart rates. They actually miss a beat every once in a while. Usually you can see it as a pattern. They'll actually have 2 normal beats, and then they'll drop a beat. And then they'll have a beat, and then have a beat, and then they'll drop a beat. So we see that here. We actually can see here peaks. So we know those are QRS peaks. To the right we have the T wave. To the left we have a P wave. And we should have that whole complex every so often. But here we're actually missing the QRS. We have a P wave, but no QRS. Okay, no QRS or T. So the signal is not going down the bundle branch to the ventricle, and the ventricles therefore are not contracting. This individual has what we call a bundle branch block. Okay, so when you're missing a QRS, the damage is to either the bundle of His or one of the bundle branches. Okay. Down here we see something called ventricular fibrillation. We actually see lots of peaks. What this is, the ventricles are are not receiving the stimulus from the conduction system, and the ventricles are actually shivering. They're really shivering like a bowl of Jell-O, and so you're not getting any coherent QRS complexes or P waves or anything. Ventricular fibrillation is very, very dangerous. These people who are in ventricular fibrillation need to be cardioverted right away, either chemically or electrically, because the next step after ventricular fibrillation is the heart stops. And this heart that's just shivering like Jell-O is not even contracting. It's not contracting adequately to pump blood. So it's just kind of like in spastic state, spasming, okay? And everything, cardiac abnormalities. We already talked about what tachycardia is, right? Just to define it, the other terminology is bradycardia. We will talk about, I think what we'll do is when we meet up again, we'll talk about ischemia and the overall control of the heart. So we're going to stop here with the pathologies, all right? And we'll do pathologies when we meet up again next week, okay? I want you guys to go and do your web anatomy stuff on